I'm going to address some of the questions that Scott posed to us, but I'm also going to take a slightly different approach. And I think that you'll find that my presentation is very complementary to Tim's, just maybe reinforcing some of the same concepts and adding a few others. So as I was thinking about this, I realized that I have essentially a number of tests that I would present in order to answer the question, do durable wood products and mass timber and timber frame structures create a net benefit for the environment, both for the climate and for other environmental concerns? So this is by no means comprehensive, but I'm just going to propose 4 things that I think about a lot. So the first is, if we produce durable wood products, and if we adopt that as a climate mitigation strategy, is that complementary or competitive with all the various other natural climate solutions that we're employing? Everything from reforestation and plantation forestry in some parts of the world, to conservation of high conservation value forests, high biomass, late successional old growth forests, other sorts of improved forest management strategies that are increasingly advocated by carbon markets. So are we reinforcing and complementing those other natural climate solutions, or are we competing with them through increased demand and intensification of forest management? So that would be the first question that I would want answered. And a big part of that is thinking about the full complement of carbon management strategies that we have available. It's not like this is a one-size-fits-all. We're talking about a portfolio of options, and we're talking about trying different things to spread the risk associated with any one of them. There's risk from a climate adaptation standpoint. There's a risk from incomplete knowledge regarding the carbon accounting. There are discount rates. There are a whole variety of risks associated with any one strategy. So we want to think about many. We can think about the 3 broad categories like reserve-based approaches, reforestation approaches, and improved forest management approaches, which is the field that I tend to work in the most. Innovative carbon silvicultural techniques that retain more carbon in the future, in the forest, and in some ways actually are conducive to growing higher quality, larger dimension trees, tightly grained, that create opportunities for high quality durable wood products. And so, we can think about a whole variety of different silvicultural systems that are coming online that are designed to do just that. And durable wood products, including mass timber, really fits here within this category. And so again, this test is designed to answer the question, are durable wood products complementary of these other strategies? Do they fit within the context of full carbon accounting and optimizing the mix of carbon strategies that we want to employ in the landscape? The second test has to do with carbon stocking, which Tim has already mentioned. And from a carbon market standpoint, and I'm not saying that carbon markets are perfect by any means, and we can really pick apart the protocol that they use and the baselines that they employ and all that sort of thing. But the one area of agreement that I would say that all the carbon market systems have, and that most scientists would agree to as well, that the sort of fundamental standard for carbon forestry is that if we're producing durable wood products, we also want to make sure that we're maintaining stable or increasing carbon stocking on the landscape. In other words, we don't want to produce wood products at the expense of the carbon storage that we already have, and then unwittingly flux carbon to the atmosphere. So what we want to be thinking about then is how we integrate production of durable wood products with the full range of carbon forestry techniques. This is just an example from one of my papers for the Northeastern US that we might employ to increase carbon stocking on the landscape. What you're seeing here on the x-axis is something like a continuum of timber harvesting options, ranging from more intensive and higher frequency harvests the type of practices that would be typically associated with high production forestry or industrial forestry to less intensive harvesting practices that occur less frequently. So things like extended rotations and retention harvesting systems. A key element of this, by the way, also is just the concept of very efficient timber harvest scheduling. If we plan out our harvests very carefully over time and space, that's another way of increasing net carbon stocking on the landscape. And so the sort of fundamental litmus test then for a lot of carbon forestry is, is the suite of carbon forestry techniques that we're using either maintaining carbon stocking, the red dotted line, or even better, increasing the net carbon stocking over time. And then that difference is what we typically refer to as additionality. So if durable wood products fit within this framework, then we've passed that test. My third test is going to depart a little bit from the strict focus on carbon, because I think that these days we understand that carbon forestry needs to be part of the broader umbrella of sustainable forestry or multifunctional forestry. And by this, I mean really specifically that through exceptional forestry practices that produce high quality durable wood products, we're also producing other co-benefits that society demands and that nature requires. And of course, there are a million different co-benefits we could think about: biodiversity and hydrologic regulation and pollination services and open space and recreation, and the list goes on and on and on. I personally have been interested in a couple very specific co-benefits, such as open space conservation and conservation of core unfragmented blocks of habitat, important for wildlife, and then also co-benefits associated with very high quality stream habitats and flood resilience. And just a quick case study to show you that these types of co-benefits can be quantified and they can actually be mapped explicitly. We did this just recently in a study that I was involved with for the state of Vermont. I'm not going to belabor the details, but just really quickly to give you a sense of how one might approach the co-benefit question. In this case study, we were interested in identifying the actual privately owned parcels in the state of Vermont in the United States that would have the greatest potential for carbon projects, that would be most eligible, in this case, for voluntary carbon markets, where one might aggregate multiple parcels into a larger carbon project and then employ those types of carbon forestry techniques I was referring to a minute ago. So we mapped out, or we used a layer representing the forested area in Vermont. That's this. We overlaid a map that ranked parcels based on their flood resilience contribution, their whole variety of criteria that went into this. And then we picked just the top ranked parcels in the 20th top percentile in terms of flood resilience rating. That's this. And then we overlaid those on the core or unfragmented forest blocks that have been mapped statewide. We buffered this a little bit. And then from this, we mapped the parcels that, again, would be most eligible, most suitable for carbon forestry, but that would also provide these other very important co-benefits to the state. And again, in particular, those were open space conservation and flood resilience. So one can integrate carbon forestry with really explicit mapping and quantification of these other co-benefits. So for me, that's the third test that increased production of durable wood products would need to pass. Are we complementing production of co-benefits, or are we competing with those? And there's a lot that we could get into in terms of how that might play out. And then with my last couple of minutes, my final test is, do durable wood products fit within an adaptive framework? In other words, if we increase production of durable wood products, does that help make our forests future adapted? Will they be more resilient to fire and wind and ice and other disturbances that we're seeing more of and that we're increasingly concerned about? And of course, there are many, many ways to approach the question of adaptation and resilience. Here's just one based on a recent paper that my lab had. And this catchy little headline here that appeared in a number of journals: older forests resist climate change better. Obviously a simplification, but let me try to explain quickly how this works. So we used US Forest Service forest inventory and analysis plots from the hemiboreal ecotone of Eastern North America. That's where temperate forests grade into boreal forests across the US-Canada border. We used 18,500 plots, so this was a big data exercise. We took those data and we applied some very interesting Bayesian statistical models. Those were fed through the University of Vermont's supercomputing cluster. It took several days to run the computations, and here's the way it all came out, or sugared out, as we would say in Vermont. So we have these carbon projections associated with forest age and development. That's the first calculation. We were interested in co-benefits or ecosystem services like timber growth and timber production opportunity. That's the next calculation. And then we looked at how those things would co-vary with habitat provisioning for a variety of different biodiversity indicators. So we used a variety of different taxa to get a handle on biodiversity outcomes. And then we basically standardized all those or set them to an equal scale. We then looked at how those would play out under various climate change scenarios. And then in the end, we get this final panel that's a little bit tricky to explain, so I'll make a quick attempt at it now. What you're seeing here is basically how well the current mix of ecosystem services holds up under climate change. And we're sort of asking the question, will future forests with climate change provide the same ecosystem services now that they're providing now, or a different mix? And what we're seeing is that with climate change, the mix of services begins to break down. Forests of different ages start providing different services than they are now. So this is really important. If we're thinking about producing durable wood products over the next 100 years, is that consistent with the other services that we want from the landscape, or will it compromise things like carbon sequestration and carbon storage objectives? What we did find is that in general, the older forests seem to be more resilient in terms of maintaining the same mix of ecosystem services that they're providing now. So again, I would want to know, do durable wood products, help us maintain structurally complex older forest structures that are providing the mix of services that we require, or are they interfering with the ability of forests to adapt and remain resilient in the face of climate change? And I'm not saying that the answer is one or the other. I'm just saying that that is the test that must be passed. So those are the 4 tests that I have for durable wood products. And